Today I am going to give you exactly 4 distinct solutions to solve the most frustrating problem a vehicle owner faces, and one of them is going to cost you roughly $3 to execute. If your vehicle feels sluggish off the line, if your fuel economy has silently tanked over the last few years, or if your engine feels like it is working twice as hard to accelerate half as fast, you are about to discover exactly why. I am going to walk you through a rapid, hyper-convenient option to fix this, a $3 DIY method. That utilizes World War II aviation engineering, a permanent structural bypass you can build with a trip to the hardware store, and a final, dead simple instant hack using something sitting in your bathroom cabinet right now. By the end of this, you will possess a level of mechanical leverage that automotive service departments pray you never acquire. But here is the part that should terrify you. When you take a sluggish, underperforming car to the dealership, the service advisor will pull out a clipboard and highly recommend a comprehensive fuel system flush. They will quote you anywhere from $500 to $800. They will hook your fuel rail up to a machine, run a generic solvent through the injectors, charge you 3 hours of labor, and send you on your way. And a week later, you will realize the car feels exactly the same. Your wallet is lighter, but the heavy, dragging sensation beneath your gas pedal remains. This is because the industry is treating a symptom of the past, completely ignoring the engineering reality of modern vehicles. Over the last 2 decades, global emissions regulations forced automakers to squeeze every possible ounce of efficiency out of the internal combustion engine. To do this, they universally adopted a technology called gasoline direct injection, or GDI. By 60,000 miles, 80% of direct injection engines lose up to 15% of their factory horsepower. You are driving a crippled machine, and the manufacturers engineered it this way to pass regulatory tests, while quietly passing the inevitable maintenance disaster onto you. Now, look closely at how this actually works, because understanding the mechanism is what gives you the power to bypass the dealership entirely. In the older engines you grew up with, fuel was injected into the intake manifold right behind the intake valves. Gasoline is an incredibly potent, highly refined chemical solvent. Every time you press the gas, a spray of gasoline would wash the backside of the intake valves, keeping them sparkling clean. But gasoline direct injection changed everything. Engineers moved the fuel injector directly inside the combustion chamber to operate at pressures exceeding 2,000 psi. The fuel no longer washes over the intake valves. It sprays straight into the cylinder. And this creates a catastrophic blind spot when combined with another mandatory engine component, the positive crankcase ventilation, or PCV system. This is where the entire industry lied to you by omission. Every time your engine fires, extreme pressure pushes past the piston rings and into the engine crankcase. This is called blow-by. It is a highly toxic, pressurized vapor made of unburned fuel, exhaust gases, and atomized engine oil. By federal law, this toxic vapor cannot be vented out into the atmosphere. It must be recycled. So, the PCV system routes this hot, oily mist back into your intake manifold so it can be burned in the engine. Your engine is literally forced to breathe its own oily exhaust. In an older engine, the continuous spray of gasoline washed this oil off the valves. But in your modern direct injection engine, the valves are completely dry. They sit at operating temperatures of around 400 to 500 degrees Fahrenheit. When that oily mist hits the blazing hot metal of the intake valve, it instantly polymerizes. The oil bakes onto the metal layer by layer, turning into a dense, crystalline, hardened carbon structure. Over 30, 50, or 70,000 miles, this carbon buildup acts like arterial plaque. It restricts the physical diameter of your engine's airway, choking its volumetric efficiency. But worse than that, the porous carbon acts like a sponge. As air struggles to get past the restriction, the engine runs lean and hot. The fuel pre-ignites before the spark plug even fires. This creates a violent, destructive pinging called engine knock. Your engine's computer, the ECU, is constantly listening for this knock. The millisecond it detects it, the computer panics. To save the engine from physically tearing itself apart, the ECU immediately retards the ignition timing. It dials back the power output to stabilize the combustion. This silent, invisible software reaction is exactly why your car feels incredibly sluggish. You push the pedal down, the computer senses the choked airflow, and subsequent knock pulls the timing, and your horsepower plummets. But before we get to the $3 trick that blasts this carbon away using fundamental thermodynamics, you have to understand why the expensive, brightly colored bottles of liquid at the auto parts store are completely failing you. If you simply want to pay for convenience, you must ignore 90% of the fuel additive shelf. Most of those bottles are essentially useless mixtures of kerosene and naphtha that burn up instantly and do absolutely nothing to harden carbon. You are looking for one specific, highly engineered chemical compound called polyethylamine, commonly known as PEA. This is your Tier 1 convenience solution. PEA is a sophisticated nitrogen-based detergent that is specifically formulated to survive the extreme heat of the combustion process. It does not flash foil and disappear. It coats the interior of the combustion chamber, soaking into the carbon binders on the piston heads and the injector nozzles, chemically dissolving the structure from the inside out. To execute this, you purchase a premium PEA-based product like BG44K or Chevron Techron Concentrate Plus. These run about $20 to $25. You pour the entire bottle into a nearly empty gas tank, fill the tank completely with premium fuel, and drive the vehicle aggressively. The high concentration of PEA will scour the fuel delivery system and restore the spray pattern of your injectors. For the driver who wants a rapid chemical solution with zero mechanical effort, this is the only store-bought liquid you should ever swipe your card for. But here is the massive, unavoidable catch that the chemical companies pray you never realize. Because your modern car is direct injected, that $25 PEA cleaner goes straight into the cylinder. It never touches the back of your intake valves. The thickest, most restrictive carbon deposits in your engine remain completely untouched, which brings us to the $3 old-school engineering trick that will physically shatter that carbon and eject it from your vehicle in 10 minutes. We are moving to the Tier 2 budget hack, and it involves a common plastic spray bottle and 1 gallon of pure distilled water from the grocery store. This is the legendary thermodynamic water decarbonization method, and it is rooted in hardcore World War II aviation physics. Back in the 1940s, aerospace engineers utilized water injection to cool the combustion chambers of heavily supercharged fighter planes to prevent detonation at high altitudes. But mechanics noticed something incredible when they tore those massive engines down for rebuilding. The internal components were sparkling clean. The metal looked brand new. They discovered that when you introduce a fine mist of water into a running engine, a violent phase change occurs. The water enters the combustion chamber, where temperatures are hovering around 1,500 degrees. The water droplets instantly flash into steam. When water converts to steam, it rapidly expands to 1,600 times its original liquid volume. This instantaneous, massive expansion creates microscopic shock waves throughout the cylinder. It causes rapid thermal shock to the brittle, baked-on carbon deposits. The carbon literally fractures, cracks, and shatters off the metal surfaces, flying out through the exhaust valves as harmless soot. To execute this $3 trick, you must follow the physics exactly. First, drive your car until the engine is fully at operating temperature. The metal must be blazing hot for the thermal shock to trigger. Park the car, leave it running, and pop the hood. You need to locate a main vacuum line that feeds evenly into the intake manifold. The vacuum hose connecting to your brake booster is usually the easiest and most central line to access. Carefully pull the hose off the manifold port. You will hear a loud hissing sound as the engine begins sucking in unmetered air, and the idle might stumble. This is normal. Have a friend sit in the driver's seat and hold the accelerator pedal steady to maintain the engine speed at roughly 2,000 to 2,500 RPM. Now, take your spray bottle filled exclusively with distilled water, set the nozzle to a fine, wide mist, and hold it near the open vacuum port. Do not pour the water. Do not squirt a solid stream. You must allow the vacuum to aggressively pull the atomized mist into the manifold. Spray once and pause. The engine RPM will bog down slightly as the liquid enters and turns to steam. Wait a second for it to recover, then spray again. Spray, pause. Over the course of about 10 to 15 minutes, you're going to feed roughly 1/3 of the bottle through the engine. The steam will scour the intake runners, blast the backs of the intake valves, and shock the piston rings clean. Reconnect the vacuum line, ensure it is tight, and immediately take the car for a hard, aggressive drive. You will look in your rearview mirror and likely see a massive cloud of white steam and black soot violently ejecting from your tailpipe. That dark cloud is the physical manifestation of your restricted horsepower leaving the vehicle. Your throttle response will sharpen instantly, and the engine will idle smoother than it has in years. And here is the part where you stop thinking about engine carbon for years at a time, because the cold reality of automotive ownership is that even after you steam clean your engine, that deeply flawed PCV system is going to start spraying hot, oily mist onto your freshly cleaned valves the very next time you commute to work. You are trapped in a perpetual cycle of buildup unless you implement a structural paradigm shift. You need to intercept the vaporized oil before it ever reaches the intake manifold. This brings us to the Tier 3 permanent fix, installing an inline oil catch can. This is a sealed cylindrical chamber that acts as an atmospheric checkpoint between your PCV valve and your intake manifold. Instead of the hot, oily blow-by routing directly into your engine, the hose diverts the vapor into the catch can. Inside the chamber, the vapor is forced through a series of internal baffles and porous bronze filters. The velocity of the air slows down, the temperature drops, and the atomized oil physically condenses. It drops out of the airstream and falls to the bottom of the canister as a thick, foul, black sludge. Only clean, dry, oil-free air is permitted to exit the top of the can and continue into your intake. Your engine finally breathes pure air, and the carbon buildup ceases to exist entirely. But automotive performance companies know how desperate people are to protect their engines. so they sell shiny billet aluminum branded catch cans for $200 to $300. It is an absolute engineered ripoff. Here is the side door secret to securing this exact same permanent structural barrier for roughly $15. Bypass the automotive world entirely and walk into the air compressor aisle of any large hardware store. You are looking for an inline pneumatic water separator. It is a small, heavy-duty clear bowl with an internal micron filter designed to strip moisture and compressor oil out of pressurized shop airlines. It utilizes the exact same fluid dynamics and physical baffles as a $300 racing catch can. Buy a high-flow pneumatic separator for $15. Walk over to the plumbing aisle and buy 2 brass hose barb fittings that match the diameter of your car's PCV hose. Get 3 feet of fuel-rated rubber hose and a few metal worm gear clamps. Splice this clear separator directly into the middle of the rubber line running from your engine block to your intake manifold. Secure it upright with a heavy-duty zip tie. Now, every few thousand miles, you simply unscrew the clear plastic bowl, dump out the disgusting acidic oil sludge that was destined to bake onto your valves, and screw it back on. You have effectively re-engineered a critical flaw in your vehicle's breathing system for the price of a fast food lunch. Now, before I show you the final 1-second trick that costs almost nothing, if this practical knowledge is helping you, hit like, subscribe to Forbidden Vaults, and drop a comment below with your own methods. It helps more than you know. We've addressed the carbon inside the engine, but there is one final, critical component dictating your vehicle's power output, and it is located right behind your engine's air filter. This is the instant bonus trick. Your vehicle relies entirely on a mass airflow sensor, or MAF, to calculate the exact volume and density of the oxygen entering the engine. Inside this sensor is a microscopic, highly sensitive platinum wire that is electrically heated to a precise temperature. As incoming air rushes past the wire, it cools it down. The computer measures exactly how much electrical current is required to keep that wire hot and uses that mathematical data to inject the perfect ratio of fuel. But over tens of thousands of miles, microscopic dust, road grime, and atmospheric oil slip past your paper air filter and bake directly onto this tiny platinum wire. The dirt acts as a thermal blanket. It insulates the wire, causing it to cool down slower than it should. It sends delayed, highly inaccurate voltage signals to the engine control unit. The computer calculates that far less air is entering the engine than in reality, so it drastically cuts the fuel supply. Your car runs dangerously lean, and you lose your instantaneous throttle response. To execute this final trick, go to your bathroom cabinet and grab a standard household cotton Q-tip and a bottle of high-percentage isopropyl rubbing alcohol. Open your car's hood and locate the MAF sensor housing on the intake tube. Unplug the electrical harness and remove the 2 small screws holding the sensor in place. Gently pull the plastic sensor out. Look down into the small plastic tube at the bottom of the sensor and you will see the tiny, fragile resistor wires. Dip your Q-tip into the rubbing alcohol. With the absolute lightest, most delicate touch imaginable, barely allowing the wet cotton fibers to graze the metal, gently wipe the dark gray soot off those tiny wires. Do not apply pressure. Wipe them until the metal shines silver again. The high-proof alcohol will cut through the baked-on grime and evaporate in seconds, leaving absolutely zero chemical residue behind. Reinstall the sensor, tighten the screws, and plug the harness back in. The next time you start the engine, the computer will instantly receive a massive, uninsulated surge of accurate, high-voltage airflow data. It will recalibrate the air-fuel mapping in real time. The off-the-line hesitation you had been fighting for months will vanish completely, replaced by immediate, crisp acceleration. So, here's the protocol. If you want the purely convenient route, pour a high-concentration polyether-amine fuel treatment into a low tank to chemically strip the combustion chamber and restore injector flow. If you want the ultimate $3 DIY hack, carefully run distilled water mist through your main vacuum line to thermodynamically shatter the baked-on intake carbon via rapid steam expansion. If you want the permanent barrier, bypass the massive aftermarket markups and splice a $15 pneumatic water separator into your PCB line to intercept the oil sludge before it suffocates your engine block. And for an instantaneous throttle response restoration, pull your mass airflow sensor and gently wipe the insulated platinum wire with a common Q-tip and isopropyl alcohol to immediately recalibrate your engine's oxygen data. The automotive dealership service department thrives entirely on your operational ignorance. They depend on you treating your vehicle like a magical, mysterious black box. That requires an $800 sacrifice every 50,000 miles. But when you understand the physical mechanisms of airflow restriction, thermal shock, and chemical solvency, you dictate the terms, and the problem loses every time.